To those who just joined, good morning, welcome. It seems like most people are here, so let's get started. You are attending a webinar by PSDM and OCS Life Sciences on the topic of ADaM. ADaM is the analysis data model developed by CDISC. It defines standards for analysis datasets and their associated metadata, and it is a required component of an EDC, of an electronic data submission to the FDA in the US or the PMDA in Japan. PSDM is a Dutch network group of statisticians, programmers, and data managers working in the pharmaceutical industry. And the aim of PSDM is to facilitate professional conduct and development of its members and to provide a platform for the exchange of expertise and ideas by organizing scientific meetings, workshops, and courses at minimal or no cost. PSDM is an independent, non-profit organization. Let's look at a few housekeeping notes now. This is a webinar, and that means that you can hear us, but we cannot hear you. This ensures that all participants can clearly understand our speaker without any disturbances. If you have any questions, we ask that you write them in the chat box, which you'll find in the control panel at the right side of your screen. And Lieke will answer all your questions at the end of the session. My name is Jules van der Zalm. I work for OCS Life Sciences as a manager, and I'm responsible for our project delivery. And next to me is my colleague Lieke Gijsbers, who is a project manager at OCS and a CDISC specialist who provides CDISC trainings and is involved in CDISC data conversion projects. I will now give the word to Lieke.
Yes, good morning, everybody. And thank you, Jules, for the introduction and all listeners for attending this webinar. And of course, PSDM for the opportunity to present during this webinar. During today's webinar, I will give an introduction into ADaM. I will explain the fundamentals of ADaM and also the different data structures. Then I will continue with explaining the ADaM Define.XML and analysis data reviews guides. And then we'll conclude this webinar with a Q&A session. So let's get started. ADaM is one of the CDISC foundational standards. And for each phase in the clinical research process, CDISC developed a standard. And that is what is displayed on the screen. For instance, well, it all starts at the beginning. So when you're really going to plan your study, when you're going to write a protocol, and CDISC has developed a model for that purpose as well. And that is called the PRM, the Protocol Representation Model. This model is less known and also not actually often used. Then for collection purposes, CDISC developed the Clinical Data Acquisition Standards Harmonization Model, which is just in short CDASH. And as I said, it's a model for data collection. So it's also describing, for instance, which items should be present on a CRF design and CRF and how well data should be collected. Then, well, I think the most mature and also most often used model, that is the ADaM model. It stands for the Study Data Tabulation Model, and as the name implies, it's a model for the tabulation of study data. It really organizes your data. And then the Analysis Data Model, or short ADaM, that one is used to well, analyze the data, so creating data sets for analysis purposes. Well, of course, there are many reasons for using CDISC standards. One of them is that ADaM and ADaM are both required by the US FDA and the Japanese PMDA, so by the regulatory authorities. But, well, it will also facilitate and streamline your clinical research processes. So if you start, well, setting up your study and you're already thinking with CDISC in your mind, then it will really streamline how you're going to convert your data or from, well, the collected data to ADaM and also to ADaM. And of course, once you're trained in the principles of standardized data sets, well, you, but also maybe as a programmer or reviewer, but also other recipients of the data can work with the data more efficiently with less preparation time because they know where to find the data and also how the data has been organized and structured. And standardized data structures also allow the development of software tools that will facilitate access to the data, but also, for instance, to make derivations or to analyze the data and also to replicate and review the data. So a lot of benefits in using foundational standards. Well, all the information about the CDISC standards can be found on the CDISC website. And here I displayed how you can find it. So here on the left side, the link for the ADaM standards. And if you go to there, then you find this icon standards, and then there are all the standards available. And one of them is ADaM. And if you then click on it, then you will get information about ADaM and also the different versions of ADaM that are available. The most recent versions have been displayed over here. So there's just a general ADaM model that describes the fundamentals of ADaM. Then there is an implementation guide, in general implementation guides that support you in, well, implementing ADaM. And then there's also a separate implementation guide that's really for occurrence data, but I will come back to that later. These are the most recent versions. Maybe worth mentioning is that FDA currently only supports ADaM implementation guides, well, version 1.0 and 1.1. 1.2 was released last year, but that one hasn't been supported according to the FDA standards catalog. And the FDA standards catalog just tells you which versions and which standards are well, allowed to use and also to submit. Well, let's now focus on the ADaM part. So ADaM stands for Analysis Data Model, and as mentioned before, it is one of the required standards for data submission to the FDA and the PMDA. ADaM defines data sets and metadata standards, and that support efficient generation, replication, and also review of your analysis results. The ADaM dataset should enable data analysis with minimal further programming, and preferably one proc away, which means that only one procedure is needed to get the final result. So it's really the idea to create data sets that really support your analysis and that the analysis can be done with minimal programming. So really making use of those analysis data sets. Well, ADaMs also support traceability. That's really one important aspect of ADaMs. It should provide traceability among the analysis results, your analysis data, and also the data represented in the study data tabulation model. So really from how was the data, so more or less tabulated, so the collected data in the SDM, and then the analysis data, which is represented in ADaM data sets, and then the analysis results, which have been, well, derived from your analysis data sets. Some fundamental principles of ADaM. The most important one is that it should be, well, that ADaM data sets should be analysis ready. Sponsors should really strive to submit analysis ready data sets, and it means that analysis data sets should have a structure and content that allows statistical analysis to be performed with minimal programming. And an analysis ready data set is just ready to be used directly by statistical programmers or by reviewers with only minimal additional processing. So only for instance, the programming and processing that needs to be done is just the sorting of the observations or just a selection of the appropriate records from your analysis data set. But at least no complex data manipulations such as transformations or transpositions should be required to perform supported analysis. So it should be analysis ready, and this approach really eliminates or at least greatly reduces the amount of programming required by the analysts and well, statistical reviewers. Well, one of the cornerstones of ADaMs is that it should provide traceability. Well, traceability facilitates transparency, which is an essential component in building, of course, confidence in the result or conclusion. So really in the study result or study conclusion. And well, ultimately, traceability in ADaM permits the understanding of the relationship of the analysis results, the analysis data sets, the SDM domains, and also the collected data or even the CRF. So there should really be end-to-end traceability. So really from collection to the results. Well, ADaM data sets should be accompanied with, by metadata, and metadata is, well, is actually data about the data. It describes the data that is being submitted. And the metadata and also other documentation should provide clear and concise communication of the analysis, including statistical methods, the assumptions, and also derivations and, for instance, imputations that are being performed. And the ADaM Define.XML, which we will take a look at later, contains the metadata for Define.XML. But I will discuss that in more detail at the end of this session. And the ADaM should also be usable by commonly available software tools. That's also one of the fundamentals. Yeah, it must just be readily usable by commonly available software tools. So just to make sure, yeah, that data sets can be used by different tools. For instance, data sets should now be submitted in v5 transport files, so XPT files, and they can be referenced by SAS and JMP, but also other tools. And Define.XML, as the name implies, is being submitted as an XML, which also can be read by different machines. So it's a machine-readable format. Well, here I displayed some differences between SCTM and ADaM. ADaM datasets are most often created from SCTM datasets. That is also what I would recommend. So if you have SCTM datasets available, then create your ADaMs from your SCTM and not from your, well, really your collected source data. But the purpose of SCTM is really to store collected data, so really tabulating data. While the purpose of ADaM is to provide a framework to support your analyses. ADaM datasets are really designed to facilitate analysis and review with minimal programming or data processing. And well, if we take a look then at origin, then SCTM is based on the source data, so it really stores your source data, while ADaM is being derived from SCTM. As I said, it could also be derived from your source data, but that is not being recommended in general, especially when you're going to submit to the FDA. Then SCTM is also required, so please then also derive ADaM from your SCTM data sets. Yes, there is some redundancy in ADaM, actually quite a lot, because in ADaM, as we said, we want to make sure that these data sets are analysis ready. And for instance, if well, certain subgroup variables are needed to perform subgroup analyses, for instance, sex, then that variable should be present in each analysis data set in which you want to perform the subgroup analysis. These kind of redundancies, well, you don't see them in SCTM that often, but in ADaM that is allowed. So, well, you can also just include variables and records that are not actually used in analysis, but are still of interest to the sponsor or the review, just well, because they would like to take a look at the data, but also maybe to support traceability. So it's really allowed in ADaM also to include records and variables that are not necessarily needed for the analyses. And again, this redundancy, the variables that you would add is really just based on what you need for your analysis. When the data structure, well, in SCTM, that's really defined by the content. And in SCTM, you have for different topics a domain. So for instance, you have a topic for demographics, you have a topic for our domain for adverse events. So it's really about the content that has been collected. But in ADaM, it is really defined by your analysis. So really what has been stated in your statistical analysis plan, what kind of analysis needs to be done, what kind of data should be analyzed. So that is really what drives your ADaM data sets. And SCTM, we have mainly text data. This really, yeah, to support the clinical review of your data. But in ADaM, we want to analyze data sets, want to really make use of the data. And then it's sometimes really helpful to have numeric versions of your variables. So a numeric counterpart. So in ADaM, you can also include numeric variables. And again, just if you need them for analysis, then you can include those numeric variables. Yes, in SCTM, the datasets are focused on one domain. As I said, okay, you have a domain for adverse events, a domain for demographics. That's in ADaM also, you can still have multiple domains, but one dataset can contain data from multiple domains. So for instance, one domain can contain disposition information, but also demographic information, maybe some treatment information. It's again just really what you need for your analysis. Another difference is really related to the date-time format. In SCTM, date-time should be put in the ISO 8601 format, which is a character variable. In ADaM, date and times are formatted as numeric dates and times, so really making use of numeric variables. Imputations, not allowed in SCTM, but are allowed in ADaM. And for instance, incomplete or missing dates can be imputed, but also if really, results like, let's say that blood pressure was measured, but one visit, but the next visit was missing, then you could also impute the blood pressure value. So imputations are allowed in ADaM. Well, in ADaM, we have three classes of data structures. Three classes have been predefined in the ADaM model. And I will explain those now just briefly, because just to get an understanding of the different structures, but I will explain those later in more detail, and then I will also provide some examples. Well, the first one, the first data structure is the subject level analysis data structure. And there's actually only one data set with this structure, which is ADSL. And this data set is structured as one record per subject, and it contains variables that describe the attributes of a subject, such as demographic information, but also, for instance, subject level population flags or treatment variables, disposition information. And it's really the purpose to, for this ADSL data set, the analysis of demographic and subject experience data. So that's really related to disposition information, for instance. But it's also a source for subject attribute data in other ADaM data sets, which means that ADSL variables can be added to other data sets. So it's really also being used as a source for other ADaM data sets. So as I said, the only one is ADSL for this subject level analysis data structure. Information about this data structure can be found in the ADaM implementation guide. So this is just a resource. Then the next data structure, it's the basic data structure, or just in short, BDS. The basic data structure captures findings data. So for instance, vital signs data, so about blood pressure or weight or height, but also lab measurements. So it's really for the purpose of the analysis of findings data. And the basic data structures, I think, is used for the majority of ADaM data sets. And the structure in this data set is just that you have one or more records per subject per parameter. And if it was measured multiple times within the study, then also per analysis time point. So just, for instance, different visits or with multiple times within a visit. And then the last predefined data structure in ADaM is the occurrence data structure. And this data structure is especially designed for the analysis of events and interventions, like medical history, adverse events, concomitant medications. And a data set in this structure contains just one or more records per subject and event or term. And as you can see, the rules or the implementation and the guidelines on how to use occurrence data structure has been specified in a separate implementation guide. And here you can see the name. So if you would like to know more, then please refer to this implementation guide. But as I said, I will also explain those data structures in more detail later. But first, I would like to continue with just some general conventions. And one general conventions and also rules, and one of them is that there are 3 predefined data structures in ADaM. Yes, about those general conventions, about the number of data sets, so the number of ADaM data sets that should be created. Well, when you're going to submit your data to the FDA or the PMDA, then the minimum requirement is ADSL. So ADSL should always be submitted. So that is a subject level data set, which has the structure of 1 record per data set. The other ADaM data sets are optional. Well, there's no requirement that, so if you have your data in SCTM, then there's no requirement that every SCTM domain has a corresponding analysis data set. An ADaM data set is only needed if the analysis could not be performed on the SCTM data set. So if you, for instance, if some concomitant medications should only be listed, and this could be done based on your SCTM data set, then you don't need to create a ADaM data set for it. So only ADaM data sets are needed if the analysis could not be performed on the SCTM data set. And if your statistical analysis plan doesn't stripe any analyses, for instance, on substance use, or for instance, smoking or anything, then you don't need to create an ADaM data set based on that information. So your statistical analysis plan really drives well, what you need to, of course, what you want to analyze, but also well, which ADaM data sets you would like to create. And eventually it's the sponsor who decides which ADaM data sets have to be created. If the sponsor says, okay, although we just need to have a listing for this data set, but I would like to have an ADaM data set, then of course that is also fine. It's really a sponsor decision, but it's not required to have an ADaM data set in that case. So yeah, there should be an optimum number of ADaM data sets. And it's really about, well, the ADaM data sets support you in creating your analysis results, and the ADaM data sets should ensure that you only need to, should allow you for minimal processing, so minimal programming when doing the actual analysis or the review of the data. That is something that should be kept in mind. If we then take a look at the data set names, well, ADSL is really reserved for the subject level data set. So that one is really fixed. And as I said, that's also the only data set that there is on the subject level data sets structure. For all other data sets, the data sets start with the prefix AD, and then the XX, what is displayed on the slide, is being defined by the sponsor. Could be either ADVS or ADLB. And it's, yeah, as I said, it's really up to the sponsor how to define this. But of course, it's really recommended to use a common naming convention, especially when you're going to submit your data. Then, of course, if you're going to submit data for multiple studies, then you would like to make sure that you do it consistently. So just to give the same names to a data set within a submission. Yeah, but eventually it's the sponsor who decides it. Maybe just one note: the ADaM data sets. So for the for ADaM analysis data sets that are not ADaM, then sometimes it's recommended to use the prefix AX instead of AD. That's just to indicate, okay, this is not a ADaM data sets. Well, then some conventions related to the variable names. Well, naming conventions for variables created with the ADaM dataset should follow the standard variable names and naming conventions that have been defined in the implementation guides. And the implementation guides, these list a predefined well, list of variables for different data structures. So for the ADSL dataset or for the basic dataset structure, and also for the occurrence dataset structure, there's a list of well, a list with predefined variables. And here we have an example. This is a section of the subject demographic variables that have been predefined for usage in ADSL. So here on the left side, we see the variable names and then the associated variable label, the type of the variable, whether it's numeric or character, if control terminology should be applied. Well, in this case, for each unit, control terminology should be applied, and then you should go to the control terminology list. Then there's a core. This is a core designation. And this column tells you whether the variables, so there are many variables predefined in the implementation guide, but not all variables are required in your ADaM dataset. And this core column tells you whether the variables should be present in your dataset. Required indicates that the variable must be included, so that's really a required variable. Then here we see permissible. These variables may be included, but that's not required. That's really up to you. If there's data for it, if it supports your analyses, then you would include it. Otherwise, you would leave it out. And then here we have an example of conditionally required. And that means that the variable must be present under certain circumstances. And the condition is then being specified in the CDISC notes. So the CDISC note just provides a general description of the variable. Sometimes it also provides examples, but in case of a core being conditional, then it also provides the condition. And as you can see here, you can see that analysis H is required if H is calculated differently than DMH. And DMH refers to the SDTM H variable, which is available in domain demographics. Well, if we then take a look at the variable names and the naming conventions, well, for the variables that have been listed in the implementation guides, you should really stick to the names and also the labels and the other metadata like the types that has been defined. So you should really adhere to these variable names and conventions. And next to that, it's also really important that if an ADaM standard variable name has been defined for a specific concept, then that ADaM variable should be used for that concept. So even if the content of an ADaM variable is just a direct copy of the content of an SDTM variable, but in ADaM it has a different name, then still you should really store it as that ADaM variable. So if there's content available, then you should use that standard variable. Well, if there's any ADaM variable then with the same name as an SDTM variable, we can see it over here. That's the case. So here we have variable H and HU in ADaM ADSL, but these are also present in SDTM DM. And here you can also see that you should copy from these variables. But if there's an ADaM variable with the same name as an SDTM variable, then it's really required that the ADaM variable is a copy of the SDTM variable, and also that its label, attributes, and values cannot be modified. So just a direct copy. That is also what you see over here. So for variables that have been listed, the first just has been stated that it should be copied from SDTM, then it should be a direct copy. But if you would like to add additional SDTM variables, which is allowed in ADaM, because in ADaM you are allowed to add any sponsor-defined variables, so including also SDTM variables or variables that haven't been listed in this predefined list, then you should still apply that rule that if a variable from SDTM is being copied, that it should just be this same variable with the same name with the same label. The only difference that it could have is just the length of the variable. That could be different. Maybe also good to mention is that, well, I can't tell all the variable naming rules that are related to ADaM just because of the limited time available. But what I would like to mention is that within ADaM, you sometimes see within implementation guides some lowercase letters. And one example is being displayed on the slide. So here you can see for age group, you can see the lowercase letter y. And when using these variables in ADaM, that lowercase letters should be replaced by a number. And well, the conventions related to this can be found in the implementation guides, but at least the letter y should be replaced with values 1 to 99. So it's really can be replaced and should not be 0 padded. So it shouldn't start with a 0. But there are also other letters. So for instance, XX or WW. But yeah, all those rules have been specified in the implementation guide to tell you how you can replace it. In ADaM, you also often see pairs of corresponding variables, and which that I mean that there's a primary variable and then there's a secondary variable, and that variable has a suffix. And it depends on whether your primary variable is numeric or character. Let's say if it's the primary variable is numeric, and you will have a secondary variable related to it, then that secondary variable should have a suffix C. And if it was the other way around, that your primary variable would be the character variable, but that your secondary variable would be the numeric variable, then that secondary variable should have the letter N. And here we also have such an example. So age group, maybe just to explain, this variable age group is a description of a grouping. So for instance, if you would like to group age values within your ADaM data set, then you can use this variable. And this is then the character description. So here we also have some examples. So for example, 18 to 65 or lower than 18 or greater than 65. But we also have a numeric version out of it. So that is the secondary member of this variable pair. That's how we call it. And as this is the secondary member, the suffix N is being displayed. And there are many, pairs in ADaM, so that you have a numeric and the character version of the variables. And as I said before, this is really to support the analysis, because having numeric variables can be really helpful in doing analysis. Then here, sometimes there's also just some SATM variables, so maybe character variables for which you also would like to include a numeric variance. That is allowed, but then you should only add that suffix N, so indicating that you are adding a numeric variant of the variable. And important to know is that when there are such pairs within ADaM, you should ensure that there's a one-to-one mapping, meaning that one value in the text value should correspond with one numeric value and the other way around. So that is really a one-to-one mapping and one-to-one relationship between those values. Well, I already mentioned before, but besides all those variables that have been predefined, you're allowed to add any other SDM variables, but also any other sponsor-defined variables. ADaM is in that sense way more flexible compared to SATM, in which SATM is really restricted to the variables that have been predefined. With in ADaM, you're allowed to add any variable that you need, again, really to support your analysis. Now we've discussed some basics of ADaM, and now I would like to continue with explaining these different dataset structures in more detail. And I would like to start with ADSL. So let's take a look at it. Yes, as I mentioned before, ADSL is required for a submission to the FDA and also to the PMDA. And ADSL has one record per subject as a structure. This is regardless of the type of clinical trial design. It's just one record per subject. It is intended to provide descriptive information about subjects, and it is also a source for subject level variables used in other data sets, such as population flags, but also treatment variables or subgroup information. This is captured in ADSL, but if you need them for your analyses also in other ADaM datasets, then it's allowed to use those variables in other ADaM datasets as well. The ADSL dataset structure allows you to merge it also with other ADaM datasets, as I just mentioned, because sometimes you would like to use ADSL variables also in other ADaM variables, but it can also be merged with SATM datasets. So if you need to create a listing and you can use the SATM dataset for it, then you are allowed to use, to merge your ADSL dataset with SATM. Yes, and ADSL is often used to create tables such as, that provides information about your subject disposition, so how many subjects completed the trial, how many subjects had to discontinue, also to provide information on subject demographics and also some baseline characteristics. Well, this is what you can expect within an ADSL. There are some required components, but also optional components in your ADSL. But the required components and required variables are being used to display study and subject identifier information, also subject demographics information, population flags, treatment information, and also trial date. So for instance, the informed consent date or the study completion date. These are just some examples. But as I said, you're allowed to add any additional variables depending on the analysis needs. So for instance, you can add baseline characteristics or numeric equivalence of certain flags, stratification variables, but also variables related to treatments and compliance, or other key visits and durations and protocol specific information. So these are just some additional variables. And let's now just take a look at a first example of ADSL. Here you can see just at first, I'm only showing you now a few variables because otherwise it didn't fit on my slides. But here you can see the structure of an ADSL data set. And as I said, it contains one record per subject. And there are some identifier variables, some variables related to demographic information, population flag, I will come back to that in my next slide, and some treatment variables. And what I now would like to do is I would like to explain the different components or different variables in the ADSL dataset in more detail. And I split the different datasets into different sets. So more or less the variables in ADSL have been grouped. And I'm just building a ADSL record in this slide. And this is just displaying the data for one subject. And the first group that I would like to explain are the identifier variables. And these variables are just used to identify the subject, but also the study. So the data for which study is the data, so to which study does it belong, site ID information. And within ADSL, these four variables are required. And unique subject ID, just similar as in SATM, should be unique across all studies within the submission. So that's just a remark. And although those four variables are required in ADSL, in all other ADaM datasets, only study ID and unique subject ID are required. You can add, for instance, site ID, but that is optional. Well, then the next group of variables that you can expect within ADSL, again, this is just an example, are some demographic variables. At least age and age unit and sex and race are required, but age group is permissible. And these variables are used to provide some demographic information about the age, the sex, and the race. And if the variables are, should adhere to controlled terminology as it has been specified in an implementation guide, then you should, of course, ensure that you adhere to it. So here, for instance, age is in line with control terminology, but sex as well, and race also. Well, here we have this example of the permissible variable age group and its numeric corresponding variable. And here we indicate that the age of 43 belongs in the age group of 18 to 65. And these variables are, in this example, just added for analysis purposes. So for instance, you would like to do some subgroup analysis based on age, or you would like to, well, at least categorize the subjects. And one of the examples is then by using this age group. And as you can see, maybe you recall it from the implementation guide section that I showed you. Here we have replaced that y value, that lowercase y value, with the number. And here we are showing age group 1, but let's say that for another analysis purpose you would like to use a different category, so maybe a second grouping of age, then you could add age group 2 and age group 2n. And well, you can add as many as you want. It again just depends on your analysis needs. Well, then in ADSL, you're expecting at least one population identifier variable. And population flags identify whether or not the subject is included in the specified population. And your statistical analysis plan will define, or well, at least should define those populations. So really based on your statistical analysis plan, you include those population variables. Here I just added two examples. The first one is displaying the safety flag. So actually, it just indicates all subjects that belong to the safety population. For these, you will have a Y value. And the second one is an intention to treat population flag. And if a subject belongs to the intention to treat, then you should set it to yes. And of course, the rules for these population flags are also available or should be defined in your statistical analysis plan. Then the treatment variables. In ADSL, you also indicate or should have at least some treatment variables. The variable arm that indicates to which treatment the subject has been randomized, and variable arm comes from your SDTM dataset DM. So it's a direct copy, and this variable is required within ADSL. Then we have the variable TRT01P, and this variable indicates the planned treatment, and 01 indicates for which period. If there was only one treatment period within a study, then variable TRT01P is sufficient. And but if you have multiple treatment periods, for instance, in a crossover study, then I would well, then you should include multiple variables, and that is what I would like to show you on my next slide. Here I have an example. On the top, you just see a parallel trial in which only one treatment was given to each subject. So either drug Y 20 milligrams or placebo. And here we only have one treatment period, so one planned treatment. And then, well, let me first go to the crossover trial. In this crossover trial example, there are two periods. Subjects receive first placebo and then drug Y, or first drug Y and then placebo. And that is, well, also what this variable indicates. This is the sequence, the planned sequence of treatments. Well, this variable is not required in ADSL, but in case your analyses are done also based on the treatment sequence, then you can add this variable. But if you then compare the next variables with, well, the parallel trial, now you can see that there are two treatments, planned treatment variables. And the first one, 01, just indicates which treatment was received during the first period. And the second one indicates which treatment was received during the second period. So it's more or less just what is the first one within your TRT sec p variable and what is the second one. And if there would be a third period, then we would also have a TRT 03p variable. So really depending on how many treatment periods there are in your clinical trial, that many TRT 0xp variables you will have in your ADSL. Well, if we then go take a look at the top, then we also see some date variables. As I said before, within ADaM, we are making use of numeric dates. And what is a date variable ends at dt. That is the convention within ADaM. If there was also time collected, then it will end on DTM. And in ADaM, you can also just display a time, just in a separate variable, and then it was just TM. So different conventions for the date times, but all those dates are numeric. So if you see a variable ending with DT, so suffix DT, then this indicates that it is a numeric date. And the format that you would like to use to display the data, that's up to you. So here we just use this format. And then there's the, well, in the ADSL, in case a treatment was given, then these variables are required. And the first one indicates this treatment start date. So when was the subject first exposed to the treatment? And we have a treatment end date. So when was the last date that the subject was exposed to the treatments? So this is just for a parallel trial in which the subjects only received one treatment. But if we then take a look again at the crossover trial, in which subjects received two treatments, in which the trial had two periods, then well, we also have those variables, just overall variables indicating what was the first treatment date and the last treatment date. So that's just overall. But we also have for each period a start and an end date. So here we can see those variables, and TR01 SDT indicates the treatment start date for the first treatment. So in this case, for the first subject, it's referring to the start date of the placebo treatment. And there, for that one, we also have an end date. And the same is true for the second period. So when was the subject first exposed to drug Y? That was on the 11th of February 2014, and that treatment ended on the 2nd of March. So for each period, there is a start and an end date, but there's also an overall date. And the overall date, well, the start date is just the earliest date among those dates, and the end date is the latest date among those dates. And here in the third row, you see an example that the subject didn't receive or never started with the second planned treatment. So therefore, these dates are empty and are missing. This about the treatment variables in ADSL. So it really depends on your trial design how many variables you will need to have in your ADSL data set. Well, then the next set of variables are the baseline characteristics variables. These are again just some examples. And but within your ADSL, you can have some baseline variables, and those baseline variables will describe some characteristics that you, for instance, would like to include in your demographics table, or that you also would like to use in any other data sets. Could also, for instance, be a covariate that you would like to include in your statistical models. So here, well, here we have an example for baseline. So BL stands for baseline, BMI baseline. And here we also have a grouping variable. So BMI baseline, but then the first grouping. So this is just a text variable indicating to which category of BMI the subject belongs. And we also have a height baseline value. Again, these variables are optional and really depend on the analysis that you need to perform. And then the last variables that I would like to explain for ADSL are the trial experience variables. And well, the trial experience variables, there's a long list of these available in the implementation guide, but there's a set of variables for related to end of study data and a set for end of treatment data. And also some additional variables like informed consent date, but also randomization date. And the randomization date is being displayed here as an example, but this variable is required if if it was a randomized trial. So here we can see rand date, and again you see that it ends on DT, so that indicates that it is a numeric date variable. And here we also have two additional variables, and these are related to disposition information, and it indicates the end of study status. That is what the first variable indicates. In this case, the subject completed the trial, and the second variable indicates the end of study date, and that was on the 28th of June. Well, here I more or less just build up a ADSL data set. Of course, it will just be one data set, but just to explain to you it in more detail and just to do it step by step, I just split those the data set in different parts. But these are some main components in the ADSL data set. There are some additional variables and items that you can add, but these are the main components, I would say. And again, the other components can be found in the implementation guides. Well, then I would like to continue with the basic data structure. The basic data structure is created for the analysis of findings data. So for instance, for the analysis of vital signs data or lab data, but it could also be used for questionnaire data. So any kind of findings data. And the structure is that it contains one or more records per subject, per analysis parameter, so more or less displaying what kind of test has been performed, and per analysis time point. But the latter is conditionally required because if the measurement was only being done once per subject, well, then analysis time point is not really needed. So then that is not part of the structure. That doesn't define the structure. Yes, the basic data structure data sets can contain observed and derived values, so really collected data, but also values can be derived. For instance, if a measurement was done multiple times on the same visit and eventually an average should be calculated for analyses, then that is a derived value, and that derived value will be present in your basic data structure data set. And yeah, any ADSL variable may be included in a basic data structure data set. Even if the variable is not used for analysis, but just for instance for review purposes, you are allowed to add any ADSL variable in the basic data structure. That doesn't mean, of course, that you should include all ADSL variables, because then your data set will become very long. But there are always, or there are at least some core variables, that is how it's being called, some variables that you would like to use, or at least would like to include in also other ADaM data sets. So for instance, those population flags that we've seen, or some subgrouping variables. And these variables can be included in your basic data structure. And the basic data set structure supports parametric and also non-parametric analysis, such as ANOVA or ANCOVA, but also categorical analyses. Also, Wilkinson-Ransom tests can be done. And as I said before, the basic data structure is the data structure that is, well, it's most often used. I would say it's the one that has the most data sets, and mostly, yeah, you also then have more than one basic data structure analysis data set when submitting data or when creating an analysis package. Well, here we already have a first glimpse of the basic data set structure. And here you can see that there are multiple records for a certain measurement. In this case, systolic blood pressure and diastolic blood pressure. These are the measurements that were performed, but that there are multiple records for a subject, for a param, and in this case also, well, it was measured multiple times, so once for each visit, and therefore we have multiple records for a param within a subject. And well, the param and param code, these provide a description of the analysis parameter. So actually the measurement that was performed. And param is then the long description, and param code is just, well, the code. It's the more or less the abbreviation that is associated with param. And again, also for these variables, there should be a one-to-one mapping. So one value in param should be associated with one value in param code, and also the other way around. So param code, these are the variables that describe your analysis parameter and the measurement that was performed. Then there's also the variable a visit. This is the full description of your analysis visits. So a text variable. And then another important variable is the parameter value, and well, or analysis value, so to say. And this contains the result of the measurements. And this could either be in a collected measurement, but it could also be a derived value. These are just, again, just the main components. And this slide was intended to just give you already an overview of the structure and also the main variables. But I would also like to show you some additional variables that could be present in your basic data set structure. And therefore, again, I build up the data set. And in this slide, I'm only showing you an example of one subject. But I also prepared some other slides with just a more complete example. But here, I'm using the same approach as for ADSL. I will just build up the data set. Well, as I mentioned, your basic data set structure can include ADaM variables. And well, at least some identifier variables should be included, and at least, well, study ID and unique subject ID are required to include. Then you could also include some, well, covariates or subgrouping variables, and that, well, from your ADSL data set. So in this case, I just added age and sex. Maybe you would like to add those as covariates in your analysis. And also the population variables were copied from the ADSL data set, so indicating to which population the subject belongs. Analysis, you would like to make a selection or perform a certain analysis in a certain population, and therefore we need those variables. So therefore these have been copied from ADSL. Also in the basic dataset structure, some treatment variables, and at least one treatment variable is required in the basic dataset structure, even in a non-randomized trial. And here we see the planned treatment, and this is a planned treatment variable for a basic data structure. And here we see the numeric equivalent, but this one is permissible. Well, this is again just for a well, parallel trial where the subject only received one drug, one treatment. But in the next slide, I prepared an example to show you how this TRTP variable will look like if a subject received multiple treatments. So for instance, in the crossover trial that I showed you before. Because this TRTP variable is a so-called record level variable, which means that it should really display on the record level, well, which treatment was associated with the value that was measured. So that is a record level identifier variable, and well, a record level identifier variable can therefore also differ within a subject and even within the parameter as is being displayed over here. But what it should represent is the treatment that was, well, planned in this case. This is the planned treatment during the measurements of these, for instance, pulse measurements. So here, during week 1 and week 2, the subject received placebo, or at least was planned to receive placebo. And during week 3 and week 4, the subject was on the drug X treatment, or at least, again, it was planned to be on the drug X. And maybe you recall it from the ADSL subsection, from the ADSL, and here a subsection is being displayed, is that the subject first received placebo and then drug Y. So the first treatment during the first period was placebo, and then drug Y. And within basic dataset structure, this information is captured in that record level variable, TRTP, which should indicate which treatment was planned on a record level, so the treatment that is associated with these measurements that are being performed. Well, next to the treatment variables, there are also some timing variables within the basic set data structure, especially when the measurements have been performed multiple times during the study. Then there should be some timing information because you should know, of course, when the parameters were measured. Here I displayed the SCTM variable. So this is just a direct copy from SCTM. This is the VSDTC vital signs date time, and it is in ISO format. Here you can see that there is an incomplete date. Within SCTM, we would just capture this as it has been displayed over here. But in ADaM, you're also allowed to include this DTC variable. But the actual ADaM variable is the ADT variable, and ADT stands for analysis date. And this DT again indicates that it is a numeric date. Well, you are allowed within ADaM to impute missing components of a date time. And that is what has been done over here. And the DTC indicates that the measurement was done in February 2012, but you are allowed to impute data in the basic dataset structure, and here it was decided to set it to the first day of February. But within ADaM, then it should at least be indicated that this item was imputed, or at least a part of the item was imputed. And that is what you do in a imputation flag variable. And this one indicates that the analysis date flag imputation variable, and this variable should indicate which component of the date has been imputed. In this case, only the day component was computed, and that is imputed, and that it should indicate the letter D. But should a day and a month component be imputed, then you would only indicate month. It should always indicate the highest level of the component that was being imputed. So if the full date was missing, then you would indicate a Y, indicated that, well, year, so that everything was being imputed. Then there are also some variables related to visits, the textual, the analysis visit, and the numeric analysis visit. This could be just a direct copy from your SCTM visits, but you could also modify it for analysis purposes. Then here we have those, I would say the most important part of your basic dataset structure variables. These are ones that we have seen before already, but then with some additional variables. And these are called analysis parameter variables. Param, as I said, it contains a description of the measurement that is being done. And it is important that param should be, the description in param should be sufficient to describe unambiguously the content of the measurements and the values that have been collected or measured. Which means that within param, for instance, you would like to include also units, but if systolic blood pressure was measured also in the supine or in the sitting position, then you would also like to include that kind of information in your param. You should make sure that your param is unique and that it really describes what kind of measurement was performed. So in this case, you could add, for instance, the position in which the measurement was performed. But for instance, in lab, you could think about specimen type that you would like to add, or maybe category. So that's really, you're really flexible in which and how you would like to define your param and your param codes. Well, param n is just a numeric version of your param, and again, there should be a one-to-one relationship. So here the value 2 was being used for systolic blood pressure, and maybe 1 was being used for diastolic blood pressure. Then analysis values, these are really the result of the measurements. So here the result was 120, and the AVAL is the numeric version, so the analysis value numeric version, but there's also a character version, AVAL C. And then some additional variables. These are all related to the baseline measurements. There's the baseline value, the change compared to the baseline, and the percentage change, but let me explain that further on the next slides. Here I have some additional records or more records. So again, here we see 1 record per subject per measurement that was being performed. And we have these param variables indicating the measurements that was being performed, the visits, and then the results. And then base indicates the value that was being measured during baseline. And this variable, analysis baseline flag, indicates the record in which the baseline value has been captured. So here you can see the analysis value during baseline was 98. And that is the value that you would like to use then as base, or should be used as base. So here it's 98 for weight, and for pulse it's 62. So base indicates the baseline value, and you repeat that for each measurement, so within a param and within a subject. Then the change, this is a variable that's most often used often used in analysis. So for change analysis, and this is just a, well, it indicates the change from baseline. So what was the result during screening? And sorry, it's the other way around. This is a mistake. Sorry, that's my mistake. This is a good example. The week 24, your analysis value is 94, and if you then compare it with your base, you just AVAL minus base, that is your change. So your result went down with 4 millimeter or 4 kilos in this example. That is a change. So change is AVAL minus base. And then the last variable is the percentage change. So as it indicates, it's a percentage, and it's being calculated by by AVAL minus base divided by base and then times 100. So in this case, again, AVAL minus base, which is actually your change. So this value divided by AVAL and then, divided by base and then times 100. These variables, as I said, are often used in your analyses, and therefore they are present in your basic data set structure. Then the final variable that I would like to explain for the basic data set structure is the D-type. And that is D-type variable belongs to analysis descriptor variable. And D-type stands for derivation type. Well, analysis descriptor variables show just special cases of values or what method was used to derive the value in AVAL and AVAL-C. And this analysis value derivation method is required when your value in AVAL or AVAL-C is imputed or derived differently than other analysis values within a parameter. So here, this D-type stands for derivation type, is average. And let me now go to the next slide, and I can explain this in a little bit more detail. Here we have a subject for which systolic blood pressure was measured two times during baseline. So we have these first 2 records, and baseline in the measurement for systolic blood pressure was being done twice. So here in AVAL, we can see the results. 125 and 121. But for your analysis, you would of course only like to count the base result only once. And well, in this example, they wanted to make use of an average. So they wanted to average those two baseline measurements. Well, what has been done? An extra record has been added, and that contains the average result. So 123 is the average of 125 and 121. And within your D-type variable, you should indicate, well, how this result was derived. So in this case, it was an average of the baseline values. And here with, again, this indicator variable, analysis baseline flag indicates that the value for eval on this record is being used as a base value. And that is what you can see over here. Well, then I also have another example. In this example, for the same subject, but there were some measurements done also on week 1 and week 3. And it was also intended to have a measurement done on week 5, but the result was missing for week 5. And as I said before, within ADaM, you are allowed to impute data. And well, you can apply different methods, but one of the methods is last observation carried forward, which just means that you take the results from the previous measurements and you will use it in the measurement that was for which the result was missing. Well, if that's the case, if you would like to apply last observation carried forward, then you should indicate in that D-type variable, derivation type, that the result in your eval was being imputed, and that is, well, LOCF can be used to indicate that. So now this indicates that this value, 120, was obtained by carrying this value from the previous measurement to this measurement. So last observation carried forward was applied. And here you can just use that record. You don't need to create a new record. You can just create that record which was intended for week 5. I would like to continue with the occurrence data set structure. This occurrence data structure is designed for capturing events and intervention data. So when you would like to do your analysis on events or intervention data, then your occurrence data structure may apply. And occurrence data set structure is really has the purpose to do occurrence analysis, which actually means that you would like to count certain occurrences. So it could be counting of subjects with a given condition or a given term or event. And here on the right, you see an example of an analysis of, in this case, concomitant medications. So how many concomitant medications were being used by subjects and then for certain treatments. And this is an example of a occurrence analysis. And the data sets, or sorry, the data that will be used for these kind of analysis should be captured then in an occurrence data structure. And well, often you see these kind of data sets for adverse events, concomitant medications, and also medical history. And also in this data set, you can add ADSL variables. That really again depends on your analysis and really the needs for your analysis, what you would like to include. And well, typically, as I said, findings data fit nicely into basic data set structure, while events and intervention then fit nicely into the occurrence data set structure. And within your occurrence data set structure, there's no eval and eval C, so no analysis value. Let's now take a look at an example. So here I just have an example of a analysis data set for adverse events, which is in the basic set data set structure. It adheres to the basic set data set structure. And the structure is that you will have one or multiple records per event or term for a subject. And for this subject, there are three adverse events. And the adverse events are being described in AU term and also some meta dictionary derived items. One of them is ADaM, that is a MedDRA dictionary-derived item, and this displays the preferred name. Well, some other MedDRA-derived items are also required, but well, that didn't fit on this slide, but I will come back to that. This is just displaying the preferred name. And you can see that there's one record per adverse event that happens. And we also have a start and end date for each adverse event. Of course, it really depends on what has been collected, but you could also impute dates if needed. And here you can see that suffix or PT indicating that this is a numeric date. And in this variable indicates the analysis start date, and here we have the analysis end date. Sometimes these are being confused with analysis or adverse events date, but that's not the case. Also for concomitant medications, if you would store that information in the basic set, or sorry, in the occurrence data set structure, and then you will have the same variables for the start date of the concomitant medication and the end date of the concomitant medication. So just these variables are being used as analysis start date and analysis end date. And here we also have some treatment variables. Well, also for the occurrence dataset structure, I would like to show you how or which different variable sets can be included. So again, I build up a data set for just one record. Well, similar as in the basic set data structure, you can include ADSL variables. So here identifier variables. What is different compared to the basic data set structure is that it is required to include your SDTM sequence variable. So this is to provide traceability, but you should include that SDTM EESEC variable in this case. But if we were creating a CM dataset, then it should be CMSEC. So identifier variables. Putting in also other ADSL variables can be included, like the covariate subgrouping variables, population variables, and also treatment variables. Well, then another group of variables is the dictionary coding and categorization variables. The occurrence data structure implementation guide provides a full list of all kinds of dictionary coding items. And there's a list specifically for adverse events coding items, so MedDRA items, but also one for WHO drug items. And WHO drug is being used to code concomitant medications. There's items specifically for these in the implementation guide for the occurrence data structure. But here I'm just displaying an example of, well, the AE term, that is really the term how it was being collected and how it's being stored in SDTM. And then we have those MedDRA dictionary derived items of the preferred term, the decode value, and the body system value. Well, then some timing variables. Well, I already displayed the STD start date and the analysis end date in my previous slide. But here you can see that the analysis start date was being imputed. And that is what has been indicated by this variable. So analysis start date and then the imputation flag. And as this value has been set to Y, it means that this value has been imputed. That's also what you can see from the original adverse event start date, which comes from SDTM. There it was completely empty, and here it has been imputed, and that is what this variable indicates. And as I said before, within this flag variables, you should indicate the highest level of the component that is missing. So, well, in this case, the day, month, and year components were missing, but year is the highest level, and therefore we just indicate Y. That is the highest level of the date components that were missing. Then you can also have some indicator variables in your occurrence data structure data sets. For instance, treatment emerging flag, and here I also have an example of the follow-up flag. These indicator variables are used for your analysis. Maybe you would like to create a certain selection or would like to perform some analysis only on the treatment emergent adverse events. Well, to explain in a bit more detail, I have another slide. Here we see two records, two adverse events for a subject. And here we have the start and the end dates for this adverse event. And on the left side, you see the treatment start date and treatment end date. Well, for the first adverse event, the first adverse event started the day after the first exposure to treatments. And in this case, treatment emergent flag was set to yes. The actual rule that you would like to use for this treatment emergent flag should be defined in your statistical analysis plan, but most often is being defined as something like an adverse event that starts after your first exposure, plus some certain number of days after the last date of the exposure. So here, treatment emergent flag was set to yes. And here I also have an example of a follow-up flag indicating that the adverse event started during the follow-up period. Similar to this, you could also have a pre-treatment flag. So just some indicator flags, and these indicator flags just tell you something about the timing of the adverse event, so when the adverse event happens. Besides those indicator variables, there are also occurrence flag variables in the OCDC structure, so in the occurrence dataset structure. And these occurrence flag variables indicate, well, when was the first occurrence of a certain event. And I will just go to the next slide again to explain this in a bit more detail. Here I have those two variables. The first one indicates the first occurrence of the of the preferred term, and the second one indicates the first occurrence of the SOC. And this stands for analysis occurrence flag, and then the P indicates preferred term, and here the S stands for SOC. And what this indicates is just when did a certain adverse event with a preferred term, with a similar preferred term, first occurred. And if we then take a look at this example, then we see as a preferred term here, the decode, that is the preferred term, diarrhea. Diarrhea happened on the 24th of January, but diarrhea also happened on the 18th of May. Well, and here the first occurrence really refers to the first time that it happened. So really in a chronological way, that doesn't have to be like this. It is really how you define first occurrence. But in this example, I just used really the adverse event that happens first. So this is the diarrhea decode, and that is this record. So therefore, this flag has been set to yes. So it's the first occurrence of diarrhea in this example. And for this record where also diarrhea happened, we leave it empty because it was not the first occurrence. Well, also for abdominal discomfort, that only happened once for the subject. Well, then that is the first occurrence for this decode variable value. So therefore, set to yes. And then we have this other variable that displays the first occurrence of the SOC flag. And that, as the name implies, is just the first occurrence for the body system. So this variable over here, which you can see. Well, for all these terms, for all these adverse events, the body system is gastrointestinal disorders. And the first time that, for the first record, we set this to yes. So really in a chronological way, as I said, that doesn't have to be your rule. But here it was set to yes for the first record and left empty for the other records because this was not the first occurrence. Yes, having said this, I would like to move on from really ADaM data to the ADaM Define.XML. And ADaM Define.XML, or just in general, Define.XML describes metadata. So it really describes your data sets that you're submitting to, for instance, the FDA. And it guides reviewers through submissions objectives, the analysis, but also the data, and for instance, data derivations that have been performed. It also includes embedded links, I will show you later, but that allows reviewers to easily access data, because with using these links you can access the data, but also some supporting documents. And a Define.XML really facilitates the review of your study data, because it more or less describes your data, and well-defined standardized metadata really minimizes the time needed to get familiar with the data. And that makes, of course, the review process faster and more efficient. And that's also really why the FDA requires you to submit a Define.XML, both for SCGM, but also for ADaM. Well, here on the left side, we see an XML. Well, it's really hard to read, as you can see. But if you open it together with a style sheet, so when a style sheet is available, then you can open it in HTML, or it will be open in HTML, and then you can really see it and also, well, read it. And I would now like just to open a example of a Define.XML, and would like to go through the different sections. Let me go over here. I'll show you what I'm doing. So here I have a Define.XML, and now I'm having a style sheet. This is displaying the style sheet, the XSL. And if I now open this XML, then it will open in HTML, as you can see over here. So here, this is something that we can read quite easily. And here on the left side, you more or less have your navigation pane. And I would like to start with analysis data sets structure. Your Define.XML, so this is an example for ADaM, provides metadata on different levels. And the first level is on dataset level. And this is the first, well, the first table that is displaying the analysis data set. So what it does in this submission, we only have 3 data sets: ADSL, ADQS, ADS, and ADE. And this just lists your data sets. It provides a description, so actually the label of the data sets. It also indicates to which class the data set belongs. So here we can see ADSL belongs to subject level analysis data set. The ADQS ADAS data set is a basic data structure data set, and then we have that an adverse events analysis data set that belongs to the occurrence data structure. You describe the structure of the data sets, the purpose. Well, for ADaM, that's always analysis. The key variables. Well, for a person not familiar with keys, these are the variables that are being used in the sorting of the data. Then you can also access the data. If I would click on this, then I would direct to the or refer to the ADSL dataset, and the ADSL dataset would be open. So these are just the ones, the blue font indicates that it's a link. So it's an embedded link, and you can click on it. And in this case, I would see the datasets then. And well, some related documentation that has been provided. And that is also really nice, because you can just access that documentation directly within your Define.XML. So this is the dataset level metadata. And then the next level is the variable level metadata. And that is what you can see over here. So if I just scroll down, then you can see over here for this dataset subject level analysis, so the ADSL dataset. For each dataset, so for each dataset that has been listed over here, there's variable level metadata specified. And variable level metadata, well, it lists all the variables that are part of your dataset, the labels, and also the keys that are being used, but also the type of the variable. Well, in the ADaM model, there's only distinction between text and numeric variables, but in your metadata, there's a further distinction. Well, there are text variables, but for numeric variables, there can be an integer, meaning that it is a numeric value, or it contains numeric values, but without any decimals. Well, if they go to a float variable, so here we have float variables, these do have decimals in it. So that's really a distinction made between integer and float variables. Then briefly, just, well, it also describes the length. So just in general, it describes all kinds of attributes belonging to your variables. Then the control terms or formats. This one indicates whether a variable was subject to control terminology and whether control terminology was being used for defining this variable. And here you can see a control terminology that was being applied for variable arm, and it also displays the values actually that are part of arm, so placebo and then so on. So the control terminology that was applied should also be indicated in your Define.XML. And then the last column of your variable level metadata indicates the origin of the data. So where does the data come from? Was it a derived item? Was it a predecessor? And with predecessor, it means, okay, it comes from your SCTM data. So here, for instance, study ID and unique subject ID, etc., were just a direct copy from my SCTM DM variables. So that is a origin type that you can use, predecessor, or as I said, was it a derived item, or another origin type is assigned. So then it just means that values have been assigned. And within this, you should also indicate for a predecessor what the predecessor variable was, and for the derived item, which derivation was applied. And if it was a value that was assigned, then you should also provide some information on how this value was assigned. So more or less you should provide a comment related to it. And if you would like to add any other information, then well, you can add it over here as well as part of the comments. So this variable level metadata is available for each data set. So here we have it sort of subject level, but also for the other data sets. So if I would scroll down, then I would also see it for the adverse events analysis data set. Well, besides the variable level metadata, there's also parameter value level metadata. And for that, I would just like to go to my slides. I would just show you briefly, because I'm seeing that it's already 11:45. Just value level metadata is being used to further distinguish your data that has been captured. So a variable has a certain type, but within that variable, you may capture different measurements. So for instance, in this example, we are having the measurements of vital signs. So diastolic blood pressure, systolic blood pressure, basal pulse rate, height, etc. were measured. Well, within your variable level, you would indicate the metadata for instance, variable AVAL-C, but that is just that variable. But the metadata may differ for the different measurements that were performed. So for instance, for height, this was just an integer, or for weight, it was a float, while even for frame size, it was actually text data. On variable level, you're not able to make this distinction because you only have AVAL-C to capture the metadata. But well, to make this distinction, there's parameter value level metadata. And this is required for AVAL or AVAL-C. So for your basic data structure data sets. And here I have an example of how it looks like. It's actually very comparable with your variable level metadata because it defines the type and the length, etc. But what is different is that it also includes a where statement. So more or less it clauses the observation. So in this case, here we are defining the metadata for AVAL-C, but only when it's only for param code equal to height. So when it fulfills that condition, and when for this AVAL-C, so when AVAL-C is when param code is equal to height, then AVAL-C has this metadata. It's an integer and the length is 3. Well, if we then take a look at the last record, then AVAL-C is a text. It contains text values when param code is equal to frame size. And again, here these values for param code frame size also had some control terminology. So that is also something that you can indicate in your value level metadata. So just a further, but it's a more detailed description of your variables. And as I said, for AVAL or AVAL-C, this is required. Go back to my slide. Yes, so we've already covered quite some components of the Define.XML. So the dataset variable, dataset and variable level metadata, the parameter value level metadata. And now I would just like to briefly show you the control terminology section. So you can click on control terminology, and then this gives you a list of all the control terminology that was used in your analysis data sets. And it could either be sponsor-defined control terminology or CDISC-defined control terminology. And this distinction is is being displayed by those numbers. If a number here is being added, then it means that it's CDISC control terminology. And this number indicates the code list number that is also available in the control terminology list. And the control terminology list can be found on cdisc.org. And for each value, there's also an ID, and that's also something that you should indicate. But maybe there's also some sponsor-defined controlled terminology. So here we have this example of age group. This was sponsor-defined. It's not part of the CDISC control terminology, but that's also something that you can add. But then you can see that there's no code attached to it. If there's a code attached, then it means that it really adheres to CDISC control terminology. Well, then just show you the analysis derivations. This is just an overview of all the derivations that were actually also available on variable level, but here then just a list of all the derivations. And this really helps the reviewer to understand, okay, how certain data items were derived. And the comments just provides a list of all the comments that were also available on variable level. Then I would like to briefly touch upon the analysis results metadata. The analysis results metadata is not required for a submission to the FDA. So I just mentioned it briefly, but this is really metadata related to your output, so to your tables, listing, and figures. And you should indicate for each table that you would then submit, or for each output, well, which parameters, analysis parameters and variables were being used. So that's what you can see over here. The reason for the analysis and the purpose, and also the data set, of course, which data set was used. But you can also provide some additional documentation, so some explanation about the table that was being created. And what you also should do is you should provide some programming statements, so really the code that was applied to get the outputs. It's just a brief explanation of what analysis results metadata entails. But for each table or listing or figure, this could be provided. But as I said, it's not required for a submission to the FDA. But it's, in short, it's called ARM and stands for Analysis Results Metadata. Then just within a few minutes, or I would like to explain the ADRG just within a few minutes. I will just open one. But actually, you can also open the Analysis Data Reviews Guide by clicking on this, because the documents are available. But let me just go over here. This is the last topic of today's session. It's about Analysis Data Reviews Guide, or in short, ADRG. And this ADRG is being used by regulatory bodies as a point of reference throughout the review process. And it provides context for the analysis data sets that are being submitted. And it contains, for instance, information about control terminology, so which versions have been used, but also which medical dictionaries that have been used, but also the data conversion and analysis process that has been applied. And finally, it also contains conformance and other issues, well, that should be explained. A template is available on the Fuse wiki, and this, well, there's actually a package, and it also contains guidelines to complete the ADRG and also some examples. But this is at least the template, and this is something, well, it's a document that should be populated while creating your ADaM data sets. So just briefly show you different sections. Well, here you see the purpose of the documents. Well, as I said, the data standards and dictionary versions that were used should be indicated in your ADRG. Then also some items related to your study, so the protocol number, protocol title, etc. should be included, so really just study-specific information. Also, a protocol design should be displayed over here. That could just be a copy from your protocol, but just the main well, protocol aspects or design aspects should be mentioned in your ADRG. That, yeah, just to make sure that the reviewer understands your study and your design. Then, well, this section really refers to your data. So analysis considerations related to multiple analysis data sets. So just some general conventions related to your data or general remarks that you would like to include. So some questions that you need to answer. So these are just some default questions that you need to answer with just yes or no. And if you would like to give an explanation, then you can do that. So for instance, are data taken from an ongoing study? It's just yes or no. That is sufficient. Some core variables. So this should list the variables that you took from your ADaM dataset and included in each other ADaM dataset. These are called the core variables. Yeah, just some general questions about your analysis datasets that you are submitting. For instance, also whether imputation or derivation methods were applied. Then you should mention and explain it over here. Then the next section is really about your analysis data creation and processing issues. Well, if you submitted split data sets, so maybe because of the size of your data sets you had to split it, then you can explain it over here. If there are certain data dependencies, well, for instance, that ADSL was used in other data sets, if you made use of intermediate data sets, some variable conventions, just some, it really helps the reviewer to understand the data that you're submitting, and that is really the purpose of this document. And then well, here in section 5, you should give an overview of all the data sets, all your analysis data sets that you are submitting, and then also the purpose of these data sets. So was it an efficacy data set or a safety data set, etc. So this just gives an overview of all the data sets. And then finally, in section 6, you should provide the data conformance summary. So when you're going to validate your data, for instance, with the Pinnacle tool, then maybe there are some issues that you couldn't resolve. And well, that is something that you need to explain over here, because the, well, for instance, the reviewer, the FDA, will also use similar tools to review your data. And by just explaining the issues that you couldn't resolve them, or there's a reason why there is such an issue, then the reviewer will understand, and he doesn't need to spend time on explaining him or himself. So that is really the idea of this reviewer's guide. This was really just in a nutshell, just to give you a little bit of an idea about this analysis data reviewer's guide. But yeah, it really supports the reviewer in his review process, as he has all the information about your study and the data sets that you're submitted in this document. Well, by having said this, I would like to well, actually start the Q&A session. I think I've covered everything that I wanted to cover. Yes, Jules, so I think we can start with the questions.
Yes, thank you, Lieke. That was excellent. There's clearly a lot to say about this topic. We have received quite a number of questions, and I don't think we'll be able to answer all of them in this session. I'll take a few, and we'll think about how that we can answer the remaining ones after this webinar. The first question that we received is about changing values in your data, and the question reads: I have clients who perceive ADaM as an option to correct database issues or to include additional calculations to avoid having to adjust the protocol or ECRF, for example, to rename visits. Is this a standard approach, and is it even allowed, is the question.
Well, it is allowed. ADaM is really flexible. The most important thing is that you keep that traceability. So if you if your collected data was just modified in your analysis data set, for instance, visits that you would like to, in your clinical study report, you would like to use different visit names, then you're allowed to do so. But you should, of course, ensure that you provide that traceability, and therefore you also have this Define.XML to explain how did I derive those items within my ADaM data set, and why do they differ, for instance, from my SCTM data. So if you can provide traceability, then it's fine.
Good, great, thank you. Another question is about the change from baseline, and it says, for my analysis, not only the change from baseline is requested, but we would also like to include the change from the previous visit. Can this be added similarly to the base and change and percentage change, and how would you indicate which record was the previous visit?
Yes, thank you. This is a question that I've also seen at some clients, so that we also had to implement it. Again, well, there are actually different ways, but how we implemented this is by just adding actually similar variables like base and change and percentage change. But let's say that you would like to calculate it from visit 2, then we would just call it base V2, change V2, a percentage change V2. So that just indicated the baseline value at visit 2, and then the change compared to visit 2, and the percentage change compared to visit 2. That is one way, so you can do it by adding columns, so variables, but you could also consider creating parameters out of it, so just adding records for it. That is also an option. Again, it's really thinking about, okay, what fits my analysis the best. So again, the analysis data sets are really to ensure that minimal programming is required for analysis. So if additional columns would support that, then additional columns can be added, but otherwise additional records could be added as well. Yeah.
Great, thank you. The clock reads 1 minute past 12, so I want to look at closing this session. Any further questions? We'll think about how that we can answer them after the session. If you have any further questions, feel free to ask them. The contact details for Lieke and myself are on the slide that you see right now. Or of course you can go to the PSDM website for further information. It's psdm.nl. We wanted to thank PSDM for the opportunity to provide this webinar, and of course to everyone in the audience for attending and for asking your questions. We will now close the session, and we wish you all a very good day.